First of all, we are moving to the preparation of ethers. So ethers can be prepared by different methods. So the important method is from alcohol. Alcohol shown reaction with protic acid. Protic acid means the acids containing hydrogen, that is H2SO4, H3PO4, okay, phosphoric acid, sulfuric acid. They undergo dehydration to form the product. Okay, so this is alkene and this is ether. What is the difference here? Here the condition is different. We need the ethers, right? So we have to use the condition 413 Kelvin. And the reagent is same sulfuric acid. Okay, now the mechanism of the reaction. This is very, very important. We are starting from the alcohol. So first one, this oxygen is using their lone pair of electron for making bond with this H plus ion. So we are getting the protonated alcohol. Now the protonated alcohol is attacking next alcohol molecule, that is they are forming, that is the next alcohol molecule is making bond with the carbon. Then this protonated part will be removing as water. See, these bonded electrons are moving here. Now here this is not an ether, right? So here the hydrogen should be removed, then only it will convert into ether. So here the oxygen is using their pair of electron to make bond with carbon. That's why the oxygen have a positive charge. Now this positive charge should be removed. So the bonded electrons on this OH bond is moving to oxygen and the hydrogen is moving as H plus. So this is ether. Okay. Primary alkyl groups are suitable for the preparation at low temperature or else either will be formed. Okay, this is the mechanism. This is very, very important. Now the next one, Williamson synthesis. This is again important name reaction. So we discussed about Coates reaction, Williamson synthesis, many reactions. So don't be confused about these reaction names. Okay. So in Williamson synthesis, we are preparing from the alkyl halide on reaction with sodium alkoxide, we are getting ether. Okay, if you move to the mechanism, the same mechanism. See, here the OH group is attacking the H plus ion, we are getting the protonated one that is attacked by the next one, C. Okay, that's it. Now, the preparation of ethers from alkyl halides. Now, we are going to prepare it from alkyl halide. So, the alkyl halide on reaction with, see here, CH3ONA, that is the sodium ethoxide, we are getting corresponding compound. Okay. Now, the preparation from phenols, we are getting the phenols can act as the phenoxide moiety. See, here the phenol on reaction with sodium hydroxide, they are producing corresponding ethers. Now the last part of this topic, that is the properties and uses of ethers. Okay, first one, the physical property. We know that ethers have a net dipole moment due to the polar CO bond. CO bond is polar because the oxygen is more electronegative, carbon is less electronegative. So oxygen density electron will move towards oxygen. So oxygen will get a partial negative, carbon will get a partial positive. That means the bond is polar. So the boiling point of ethers are almost as alkenes but lower than that of the alcohol due to the hydrogen bonding. Because in case of alcohol there is hydrogen bonding. That is the reason. Okay, now due to the hydrogen bond formation, alcohols and oxygen in ether, it is miscible in water. So miscible means they are soluble in water because they can form hydrogen bond with water. Then ethoxy, ethane and butane 1-mole are soluble while pentane is not. That is also important. Okay, now the chemical reactions of ethers. We are moving to the chemical reactions of ethers. So the first one, the cleavage of CO bonded ethers. Ethers react the least among the functional groups. See here, either group is among the other groups, either group is the least reactive one. So the reaction with dialkyl ether with alkyl halide. See, if you the ROR reaction with hydrogen halide, they are producing the corresponding alkyl halide. So here the CO bond cleavage in the ether is taking place and we are getting the alkyl halide. See, if you are taking alcohol, the same thing will happen. The bond of alkyl aryl ether is broken and alkyl oxygen bond is less stable than that of the aryl oxygen bond. Here, see, the alcohol is the ether is there, the OR bond they are converting into phenol. Okay, and ether is also broken by concentrated alkyl halide at high temperature. So this is another reaction. Here the alkyl halide is producing. So in all these reactions, you can see the bond between alkyl group and oxygen. Alkyl group means carbon and oxygen is removing. That is breaking. Next one, see here the mechanism. Mechanism is simple. See here the same thing. The hydrogen alkyl halide is there. The oxygen is attacking the alkyl halide by using the lone pair of electron. Then this either become protonated. The same thing that we did in case of the previous examples. And the second step, we can see the I minus ion is attacking the carbon. Then you are getting the intermediate. So here the bond breaking is taking place here. So CS3I alkyl iodide is forming, and this will convert into alcohol. This is the bond breaking position. Okay, so this is the SN2 mechanism. Now, here, when HI is present in abundance and the reaction is carried out at high temperature, ethanol will interact with another molecule of HIC. If the HI is regenerating here, there means here the alcohol is there, right? So they can undergo other reaction. For the reaction C, here the hydrogen iodide is reacting with the next the formed alcohol molecule and producing another product. Okay. The tertiary halides are formed in the presence of tertiary alkyl. So these are the reactions. See, some examples are there. Just go through the examples. See here, the either is there reaction with hydrogen iodide, alcohol, and corresponding alkyl halide. Okay, that's it. Next one is electrophilic substitution reaction. Either in the same way phenol, how the phenol is reacting in the same way, this compound is also undergoing resonance. So electrophilic substitution is possible. First one, we are doing halogenation. This is the resonance. See, jumping of electron is taking place. So the ortho and para positions will be occupied by the electrons. Electron density is concentrating on ortho and para position due to the resonance process. So in the halogenation, you can see halogen is substituting in the ortho and para position. So we are getting the same thing that we did in case of phenol. We are getting mixture of ortho and para isomer. See, in the Friedel-Crafts reaction means we are substituting alkyl group or acyl group on the compound. So the alkyl and acyl groups are introduced at the here again see ortho and C. In either also similar to that of the phenol, ortho and para position is the points where the substitution is taking place because of the electron density is concentrating in ortho and para position due to the resonance process. So here, this is alkylation. We are getting mixture of ortho and para. This is acylation. We are getting a mixture of ortho and para. This is COCH3 is called the acyl group. Okay. Next one, nitration. We are doing the nitration. We are getting the same compound. Ortho and para products. Okay. That's all about the reactions.